friends, welcome to Jitesh classes. Today we will start fluid statics part 3, session 3. In last session part 2 I explained atmospheric pressure and average pressure on the side walls and random shaped vessels. Those all I explained those cases. And before video, if you didn't saw those two videos, the links are in description. Now we will start the session. This is a case, small case. Fluid pressure depends on the shape of the vessel or not. See, in this first one, these are of different shapes. This is a vessel. This all is same vessel. This total, but the containers, these lids all are of different shapes. See, from here we are dropping some liquid, pouring some liquid, and it is filling through this, and it is filling. Totally, it was filled. These, if you take, these are of same level. If you can take, or H1, H2, H3, H4 are equal, you can take, or they may be different. But PATM is acting for every different shade. One PATM. This will take same level, one level. See, this level, these all are of same level. It means that all are of same height H. We already learned that P is equals to H rho Z. See, pressure is equals to H rho Z. We will take this liquid rho. This liquid's density is rho. Okay, we will take this liquid's density rho. Here pressure is equals to H rho Z. We got that formula. Here, so at the same level, all these will be equal. Means same level, pressure will be equal. So we will take here P1, P2, P3 and P4. Okay. So P1 is equals to P2 is equals to P3 is equals to P4, because they are all of same height, and is equals to PATM is acting downwards. In atmospheric pressure, I said that PATM plus H rho Z. This is the pressure at this point. It means that fluid pressure does not depends on the vessel. It means that does not depends on the shape of the vessel. So it depends on the height, density and gravity. G is acting downwards. So gravity, it depends on those three. And the PATM, atmospheric if it is closed vessel, then atmospheric pressure is not acting, then some changes will be. The atmospheric pressure will be taken out and it will be neglected. So we can conclude from this one, we can conclude that pressure does not depends on shape. We got that. If we take this one, case 2. Okay, this is of density rho, this liquid. See, we'll take at a level, this level. See, this level. Here we'll take here P1, this point P1. This is P2, and here this point is P3, and this point is P4. Okay, is it okay? Now this is of height H. See, from the top, from this point, this is of height H. PATM is acting here. So similarly, how we did this also same. See, pressure is equals to P1. See, they are at the same level, so pressure will be equal. So P1 is equals to P2 is equals to P3 is equals to P4 is equals to P ATM plus H rho Z. So from this we can conclude that fluid pressure does not depend on the shape of the vessel. It depends on the height, density and gravitational force acting on it. Now, Archimedes principle. See, this is a spring balance. Okay, this is spring balance and this is of 1 kg. This is of mass 1 kg, this body, and this is not submerged. See, Archimedes principle means that if a body is partially or completely submerged in water, how much water is displaced? If it is submerged or partially or completely it is submerged in water, then how much water is displaced in another container or something? How much liquid is displaced? The weight of that, the force mg of that is equals to buoyant force. Okay. See here, it is 10 newtons because it is carrying that mg. See, upward it is carrying tension, it is carrying downward 1 into 10, 1 into gravity, 1 into 10 it is acting, so upward is 10 newtons. With 10 newtons it is at equilibrium. So water is not displaced. Water is not displaced. Here 0 newtons and 0 newtons. So for buoyant force is 0. Okay. When buoyant force is active, I will say now. See. See, same 1 kg liquid, see, same case, same 10 newtons, same case, see, 1 kg, when it is submerged in water, okay, when it is submerged in water, this is submerged, we will take some water, okay. kg. Here, if the weight, if the mg, the displaced liquid is acting downwards, some 3 newtons, okay, some weight is displaced, means then what happened? It is submerged, completely submerged in water. Then the body will try to float upward, so float on the water. So some force is acting by the liquid to make this body float on it. So that one is called, and that makes it to be at stable equilibrium in liquid. So here then 3 newtons means 7 newtons. 7 newtons is acting, then 3 newtons is displaced, and so here it is this is spring balance. Spring balance is not exerting more pressure. 7 newtons it is not applying. It is not pulling because 3 newtons of water liquid is displaced. So it is equal to buoyant force. Then buoyant force is applying the 3 newtons. So it is applying only 7 newtons. Then it will be submerged in the liquid. Means buoyant force is acting by the liquid to make the body to float on the water, that it is applying some so Archimedes principle says that how much liquid is displaced due to the submersion, that much is the buoyant force. So the buoyant force is acting upwards to make the body float. So it is acting 7 newtons. This is buoyant force. Simply Archimedes principle says that buoyant force is equals to how much water is displaced, how much liquid is displaced, how much fluid or liquid is displaced due to the submersion of a body. Now I will say derivation of it. If we take a body like this, and this is of area S. Better we'll take cylinder to represent the area correctly of the base. Okay. Area. This area will take A. Okay. PATM is acting downwards. PATM atmosphere is acting some pressure on this water, liquid, fluid. Okay. And this fluid is of density rho. Here this point will take will take some x and y. Okay, see here the height will take height h1, this up to this top of the cylinder, and here we will take from the top of the cylinder to the bottom of the cylinder, we will take height as h2. Okay, and F1 is acting in this one, F1 is acting from upwards, and F2 is acting from downwards. Okay, see pressure, see we will take here, okay, here the pressure will be P1, see at this point pressure will be P1 and pressure will be Px, P2. We can take Px or Py, so we will take Px here. Okay, instead of P1 we will take Px, and here Py we will take instead of P2. Okay, now Px is equals to, see Px is equals to PATM, atmospheric pressure is acting in this direction, plus H1 rho g, here to here. Next Py at this bottom, so here H1 rho g PATM plus H1 rho g is up to here, plus H2 rho g for up to Py H2 rho g plus H2 rho g externally, extra is adding. Okay, H2 rho z. Now H2 rho z plus H1 rho z. See, this is H1 rho z. Okay, clear up to here. Next, force F is equals to, see the pressure is acting more at here now, so we will take the, for here, up to here also we will take the pressure which is at here, we will take the area which is at here, so area A we will take. F1 is equals to PATM plus H1 rho z into A, and F2 is equals to PATM plus H1 rho z, H1 plus H2 into rho z. Rho z will take common, and H1 plus H2. Okay, see force of buoyancy means here force is acting from downwards by the liquid, and F1 is acting from upwards, but it is exceeding it will exceed than this, because here pressure will be more. So that is buoyancy force, buoyant force. So buoyant force, it means it is acting, the force, buoyant force is that the force acting by the liquid. See, force due to liquid, due to fluid or liquid. This is an important point. Force, buoyant force is that force acting by the liquid. Okay, so F2 minus F1 is our buoyant force. Means the force, actually the force, extra force which is acting on the which is acted by the liquid on the body, which is pushing it upwards, and that will be at equilibrium upwards. See, this is acting upwards, and this one, so the up to some extent how much it is acting, that will be that will go up to there, and it will be at equilibrium. So here F2 minus F1 means PATM. See, PATM minus PATM. See, PATM. See, I will write clearly. PATM into A plus H1 rho Z into A plus H2 rho Z into A minus PATM into A plus minus H1 rho Z into A. H1 rho Z and H1 rho Z will get cancelled, minus H1 rho Z and plus H1 rho Z. PATM into A, PATM into A will get cancelled. So F2 minus, see, F2 minus, I love it. See, force of buoyancy is equals to F2 minus F1 is equals to H. See, H2 into area rho Z. Volume is equals to height into area. Height into area. So we will take it is equals to, this is solid, okay, solid, Vs into rho G. Fb is equals to Vs into rho Z. This is Archimedes principle derivation. Now law of flotation. Law of flotation. How, if we take a liquid in a container, in a vessel, in that a stone is dipped in that of mass m. This is of mass m. See, mg is acting downwards. It will be at equilibrium. How? Fb is, it is partially submerged in water. Okay. Force of buoyancy is V rho Z. Volume into rho into G. We got that already. So Fb is equals to weight acting downwards is equals to mg now. So V rho Z is equals to mg, and m is equals to, means here we got that V rho Z is equals to mg. With using this, using the buoyancy force is acting upwards and mg is acting downwards, so that will be, those both will be equal, and the stone or some body will be at equilibrium. So that is the law of flotation. Okay. Thanks for watching this video. If you like my explanation, kindly like, share and subscribe to my channel.